So I'm creating a new module. So this is I'm calling it a queue this time. I'm going to do some testing. So I've imported quick check. And I've also imported my slow queue, my queue slow, and I'm going to call it slow in this context, and I'll show you what that means. So what I have now is the same template I had before. I want to implement exactly the same interface. The implementation is undefined, and I'm going to use a couple of lists, but I'll show you that in a moment. Okay, so let me just save this and see if we can run this. Okay, so we've compiled the skeleton version of this code where everything is undefined except the data type, which I'll talk about in a moment. But the main thing I wanted to show you at this point is that we have access to the slow implementation of a queue. And we have that access by slow dot and then the name of any of these functions, like empty for creating the empty queue, or slow dot add one to the slow dot empty queue, and we create. So we have access to the old queues. You notice that the show function doesn't use this name slow; it still uses queue. But we don't get mixed up between the two kinds because we have two different constructors. And in particular, we have the slow queue constructor, which is the thing which, when you give it a list, gives us the slow representation of a queue of things. So this is the queue constructor from the old implementation, and the new one will now be called queue. Now the reason we're doing that is because we're going to use the simple original implementation to help us test the implementation that we're constructing here. Okay, so let's have a look at the implementation. Okay, let's look at the implementation then. So as you may have noticed, we're going to represent the new kind of queue. That is to say, implement the queue using two lists, one list to represent the front of the queue and another list to represent the back. And so, for example, the empty queue will be represented by an empty front and an empty back. When we add an element to a queue, we're going to add an element, well, let's call it A, onto the front of a queue, which has a front and a back. And what we get by doing that will be a queue where we take A and put it on the front of the front, and the back of the queue is unchanged. Is that right? No. It was just in the same way as before. The A doesn't go to the front of the queue. If you just join a queue, you don't go to the front, you go to the back. Now in the old version, we had to use the append operation to put the A to the back of the queue. But this time, the back of the queue is represented in reverse order. So the newest guy will be put on the front of the second list. And we go back to our slide, that picture that represents that. When a new guy comes in, we put the new guy on the front because these guys are represented in reverse order. So the back half of the list, the back chunk of the list, will be represented in reverse order. And that's what makes this queue a fast queue, because it's quick to add somebody and quick to remove somebody. Okay. What about removing somebody from a list? Well, this one requires a little bit more pattern matching. We can remove somebody from a non-empty list. So what does a non-empty queue look like? Well, we're going to remove whoever's at the front of this, and let me just put an underscore there to indicate that I really don't need that. And the result of that will be a queue with just a front and a back like this one here. So we've matched against a queue, and where the front of the queue has something on the front, we've thrown it away and given the slightly smaller queue. And the front uses a similar pattern match, not quite the same. In the front, we actually care about who's at the front of the queue, but what we don't care about is what the rest is, or what the rest of the queue is. So I'm going to use under don't care patterns here to indicate that. So let me line those up a little bit. And the final case is when a queue is empty. So when is a queue that looks like that? There's a general queue empty. Well, it's empty precisely when the front is empty and the back is empty. but that's our first attempt at representing queues using two lists rather than one. So this is how we're going to test this guy. So I've already got the code here ready. We're going to convert queues using this data type into the old version of queues that we had on the previous module, the slow queue that we're calling them here. And we're going to convert this kind to this kind in the following way. We take the front of the queue and the back of the queue and we join the two together. But we join them together into one list in such a way that now the back has to be reversed, because this is represented in reverse order. So we get a slow queue representation from the fast queue by joining the front to the reverse of the back. So we have a conversion function. And the conversion function allows us to state a bunch of properties, a bunch of invariant properties that relate this implementation